In this section, we're not going to learn like a new type of equations that as we did before. Like we learned linear equations, we learned this. But what we're going to do is we are going to take three different types of differential equations and try to transform them into an equation that we already learned something about. Okay, and those three equations are named by the name of the people. Now, the people who found them. The first one is called Bernoulli equation. Bernoulli differential equation. And what is Bernoulli differential equation? Bernoulli differential equation is the kind of equation that is written in the form dy dx plus p of x y equals a function in x times y to the n. N is taken from real numbers, any real number n. Note something, if n is 0, y to the 0 is 1, then you will get what? We get the linear differential equation. So if n is 0 or even 1, this equation transforms into the linear differential equation that we just covered in the previous section. So what do we have to put? A condition here. If y is not 0, we can divide the entire equation by y to the n. So we get y to the negative n dy dx plus p of x y times y to the negative n, so it's y to the 1 minus n, equals f of x. To solve such kind of equation, the procedure is this. We let w to be the y minus n, this term here. And keep in mind, n cannot be 0 and it can be 1. Otherwise, it's linear. Then what we can do here is differentiate both sides with respect to x. So dw dx is you bring the 1 minus n down, y, 1 minus n minus 1, that's a negative n, dy dx by the chain rule. Call this equation, I just call star. Substitute into 2 star to get dw dx plus 1 minus n p of x w equals 1 minus n f of x. And then what do we do from there? We just solve this. Solve and substitute back the y to 1 minus n to be w. So Bernoulli found this trick where you take w to be y to the 1 minus n and then differentiating both sides with respect to x, substitute back into the given equation or the equation we had earlier, we call the star, and that will actually solve the problem for you. I'm going to take this example dy dx plus 1 over xy equals xy squared. A lot of books use the same example. So now notice, how do I know this is a Bernoulli? This is not linear. If this term here was not there, then that would look like a linear. So what we do here is, that is a Bernoulli differential equation. And why is it Bernoulli? Because it's written in the form of dy dx plus p of x. So this is our p of x, and this is our f of x, and this is y to the n. So in this case, n is 2 here. And since we realize it's a Bernoulli differential equation, we start with w equals y to the 1 minus n. Y to 1 minus 2, it's y to the negative 1. You may differentiate both sides with respect to x to get a negative 1 y to the negative 2 dy dx. Now we're going to get rid of everything or transform it from the y into w's, because notice what we have here, this, no more y's. So now what do we get here? You can either use that form that I just boxed, or you can go step by step with substitution. If you want to use that form, that would be the easiest thing if you know it. So you write dw dx plus 1 minus n, so 1 minus 2, p of x. P of x was 1 over x. W equals, it says 1 minus n f of x. F of x was x. So here on the side, f of x is x, n is 2, p of x is 1 over x. So let's see what we get. dw dx minus 1 over x w equals negative x. Now notice something about this. Now this is a linear differential equation. So Bernoulli's method and the method of the other people like Ricatti and Clairaut, what they did, they found tricks to transform these equations that we're going to see in this section, the 3 forms of them, to transform it into something simpler, like this one transformed into a linear differential equation. And what we do is we are going to solve this now using what we learned in the previous section. So we're going to find the integrating factor here, e to the negative 1 over x dx, e negative natural log of x, e natural log of x to the negative 1, x to the negative 1, or 1 over x. Then, watch carefully here, we did d dx of the I of x times y. Here's not y, it's a w. Right? Equals whatever is going to go here. This, if we multiply this equation by this, that's going to give us negative 1 on this side. So d dx of x to the negative 1, w is negative 1. Integrating both sides, which is negative x plus c. You know, it would be nice if you multiply everything by x, we get w to be negative x squared plus cx. But don't forget to go back and replace the w with what? What was w? W is y to the negative 1. Y to the negative 1. Because originally we wanted to solve for y. And now this is 1 over y, which is over 1. You can flip both sides to get y. 1 over negative x squared plus cx.
Oh, Professor, could you scroll up a little bit?